Hey, thought we'd try to do another integral today. We have one here on the board from MIT 2011. This was problem number 9. We have the integral of cosine of the 6x dx. The interesting thing here is this is really not a hard integral. I think the reason they put this one on here is because it can be time consuming and messy, easy to make silly mistakes. I think this is really about finding an efficient way to do it. Let me know in the comments if you found a better way to do this. But for me, what seemed like the cleanest way personally was just using the power reduction formula for cosine. Okay, so typically I don't like to use formulas all that much, but in this case, I think it's pretty useful because we can do this very systematically. What this formula here allows us to do, so we have an integral, we have this integral with some exponent n. So in this case, it's going to be 6. So like this integral here, we could call I sub 6. Now the catch is this isn't really solving the integral for us. All it does is allows us to reduce the power. If we're dealing with I sub 6, we'll have one term out front, and then we'll have another integral in terms of cosine of the fourth. So in order to get to our actual answer, I think we're going to have to apply this 3 times. Okay, so to get into it, I'm going to do is just going to apply this formula as we have it. So we're going to look for our I sub 6 value, and we'll use this. So our first term here, n minus 1, so 6 minus 1, we're going to have a cosine to the 5th x, sine x over our n value, which is 6. And here, 6 minus 1, we're going to have 5 over 6. I sub n minus 2 is going to be I sub 4. And so just to be clear, I sub 4 is the integral of cosine of the 4x. Okay, and like I mentioned, we're going to have to do this multiple times. So let's find our I sub 4 value using the same formula. So we're going to have, again, n minus 1, so we're going to have cosine cubed x, sine x over 4. Then here, 4 minus 1, we're going to have a 3 over 4, I sub 2. Now here, this integral is just the integral of cosine squared x. We don't really need a formula for that. That's pretty easy to integrate. But I'm going to do it anyway because we have the formula here, so let's just use it. It's going to be just as easy. So for our I sub 2 value, we're going to have cosine of 2 minus 1. So that's going to be just cosine of x, sine x over our n, which is 2. Then here we're going to have 1 over 2, I sub 0. Okay, but for I sub 0, that's just going to be cosine of the 0. Cosine of the 0 is 1, so this is just dx. So this I sub 0 value is just x. So now for our solution, all we need to do is work backwards. I'm just going to take my I sub 2, we'll plug it back in here. Then we'll get I sub 4, and we'll plug it back in here, and then we'll be done. Okay, so what I've done is I just substituted our I sub 2 value back in here. So when we distribute in our 3/4, we're going to keep this first term. Okay, the cosine cubed x, sine x over 4. Then we're going to have 3/4. Actually, we're going to have 3/8 cos x, sine x. And then we're going to have 3/8 here, just 3/8 x. But now we got to repeat this one more time. So we need to take this value and plug it in for I sub 4. Okay, so I've just taken my I sub 4 and we plugged it in right here. And now all we need to do is just simplify this, multiplying in our 5, 6, and then we can get our final solution. Okay, so we brought down this first term, then we're going to multiply in our 5, 6. So we're going to have 5 over 24 here, multiplying 6 times 4, cosine cubed x, sine x. Now when we multiply 5, 6 times 3/8, a 3 is going to cancel with a 6, and we're going to have 5 over 16, I believe, cos x, sine x. And then here it's going to be, again, the same thing. We're going to have 5 over 16 x. Give it a plus c, and that's it. We're done. Pretty long expression. So it's like I said, multiple steps, but I didn't think it was too bad just doing 3 steps like that. So let me know if you had a better way. I'd be interested to hear. That was the best I could come up with. Thanks everyone. Appreciate your watching. Have a great day.